So now what we are going to learn is the next chapter in chemistry, that is chemical bonding, the second chapter. We'll be referring Viraf Dalal for this thing as usual. Now we know that each and every element is made up of what you know as atoms. So atoms are the one with which an element is being made. And this particular atom has got the protons and the neutrons at the nucleus, and then there are these orbits or shells in which there are electrons. So these are electrons over here. Now we can see that each and every atom which is going to be there, it needs to acquire a stable state which is called as completing its duplet in case of only first shell. So if an atom is such that it has got only one shell, that is proton, neutron, and then only one shell, then it needs to complete its duplet so that it becomes stable, or it needs to complete its octet if it is any other shell, that will be 8 electrons. So here it is 2 electrons and that is 8 electrons. So it needs to have 8 electrons, and 1, 2, 3, 4, 5, 6, 7, 8. It needs to be like this, 8 electrons in the outermost orbit, maybe in the thickness shell or third shell or fourth shell or fifth shell, but the last orbit or the last shell should have 8 electrons. And not more than that, not less than that. Of course, more than that is not possible. So it should not have anything less than 8 electrons in the outermost shell for completing its octet. When it completes an octet, it becomes stable atom, and when it becomes stable, it can be available freely in nature. So it can exist freely in nature only and only if this particular orbit, the outermost orbit, is completed. So to complete this orbit, the atoms are either going to give away its electrons or accept some electrons or share electrons with other atoms so that they can complete their outermost orbit and they can resemble their electronic configuration to the nearest inert gas. So this particular process, what basically happens is that an atom is going to lose or gain or share electron and become a molecule. This molecule will be the one which will be available freely in nature. So the existence of any element to be available freely in nature is possible only and only if it is formed into a molecule, which means its outermost shell has got 8 electrons if it is the second or the third or the latest shell, or it has got 2 electrons if it has got only one shell. That is, it has completed its octet or duplet. So accordingly, when we see a particular atom, we can see that the electronic configuration, due to the electronic configuration, the last orbit may have 1 electron, 2 electrons, 3, 4, 5, 6, 7 or 8. These are the possibilities of the number of electrons being present in the last orbit. Now if it is 8, we don't need to see it at all because it is inert, it is stable. So this is stable because it is inert gases. So that solves the purpose. So everybody wants to imitate this. All these ones want to become 8. So if we see this example over here, so here the electronic configuration could be 2, 8, 1. So if this 1 gets discarded, automatically it will become 2, 8. So the last orbit has got now 8. That means it is achieving the stability. So that is the reason 1, 2 and 3, these ones will lose electrons. There will be loss of electron. They will lose electron so that they become stable. Because they are losing electrons, they are electropositive in nature, and that's the they are the one which are going to be forming into a positively charged particle. So that is why after losing the thing, they become a cation. So they are going to form into a cation, and hence they are called as metals. So metals are those positively charged ions. So metals, when they lose 1, 2 or 3 electrons from the outermost shell, they become negatively charged ions called cations, and they they are going to form into a positively charged, they are going to form into a positively charged ion known as the cations, and they are going to be metals. So 1, 2 and 3 are metals because they are going to lose electrons, and since they lose electron, they become a positively charged ion. Why is that so? Let's see that thing also. So suppose we have got over here a atom, that is sodium, which has got P is equals to 11 and E is equals to 11. So if it loses 1 electron, the E becomes 10 and this is still 11. So automatically it is no longer neutral. Now this becomes a positively charged ion. So this is plus 1. Okay. So this becomes a positively charged ion called as the cation over here. Similarly, if we are having the one as 4, 5, 6 and 7, normally the 5, 6 and 7 much more, these ones are going to gain electrons because this can gain 3, this can gain 2, this can gain 1. So when they gain electrons, they are going to become an anion. Anion is the one because they are going to gain electrons, means they are going to become negatively charged particles, that is anions. Then that is why they are called as non-metals. So they will be non-metals. Okay, this will be non-metals. So what are the non-metals? The non-metals are those those substances or those elements having the valency as 4, 5, 6, 7. Okay, 4, 5, 6, 7 as the valence electrons in the outermost shell, and they are going to gain electrons. Normally gain of electron will be only gaining 1, 2 or 3 electrons. 4 electrons gaining not possible, but yeah, but that is in the part of the non-metals. So they will be gaining 1, 2 or 3 electrons, and they become what we call it as anions, which is a negatively charged particle. Why do we want to be an anion? We can see by this formation. Chlorine, which is 17, which is having 4 P as 17 and electrons as 17, it is going to gain 1 electron and become 18. So now the P is still 17, protons are 17, but the electrons are 18. So this becomes chlorine minus 1. So this is how the non-metals become negatively charged particles. Okay, simple. So now, once you know that the basic purpose of the transfer of electrons or sharing of electrons is for having a stable electronic configuration. But when they do so, they are going to form into what we saw it as molecules. Now these molecules which are going to be formed, they would be formed of 2 kinds. There will be 2 kinds, in fact more than that, but mainly the 2 kinds of molecules are going to be formed. The 2 kinds of molecules will be formed will be the one in which firstly is, like for example, if it is Na and it has already lost an electron, it becomes Na plus, and Cl, he has gained electron, it becomes Cl minus. The positively charged ion over here and the negatively charged ion over here are going to have a force of attraction between the two because the opposite charges attract each other. Since the opposite charges attract each other, these two are going to attract each other and form into a bond which is nothing but NaCl. So the formation of NaCl is going to take place when a electrically positive charge and the electrically negative charge, that is nothing but a anion and a cation, are going to combine together to form a stable molecule. So that is the one which is called So this thing has taken place due to transfer of electrons. So it is due to transfer of electrons. So because the electrons have got transferred from here to here, that is why this particular process has taken place, and hence this is called as electrovalent bond or ionic bond. Why electrovalent bond, ionic bond? Electrovalent because it has got a electronic sign, it has got a particular charge on it. So it is formed into an ion or electrovalency. Okay. So metals, therefore we can understand it also this way, that metals and non-metals combine to form electrovalent bonds by transfer of electrons. The metals lose electrons, the non-metals gain electrons. The next thing is possible when, like for example, if one chlorine is there and another chlorine is there, and this has got 1, 2, 3, 4, 5, 6, 7 in an outermost shell. This has got 1, 2, 3, 4, 5, 6, 7 in outermost shell. Then these two electrons over here are going to be shared by both of them, such that if this is asked how many electrons it gets, then this gets hidden and it has got 8 now. And if this is asked, then this has got 8 now. So accordingly, both of them are going to share one electron, forming a single bond between the two, which is called as a molecule of chlorine, which is Cl2. So a single bond, that is sharing of one electron between two atoms of chlorine, gives rise to a particular molecule, which is always going to be there only in case of non-metals. Only non-metals can form such kind of a bond, because metals, even if they share, they cannot complete, because the maximum number in metals, what is the maximum number of electrons present in the last orbit? 3. 3 के साथ दूसरा 3 शेयर हो भी क्या तो इससे 6 होगा. You cannot complete 8. Therefore metals will never ever share electrons. Metal will always give away electrons. Non-metals can accept electron if it is available, but if the electrons are not available, they can share electrons with each other and becomes a stable compound. So that is why chlorine, the formation of chlorine molecule is going to be there, which is nothing but due to sharing. Okay, that is because of sharing of electrons. And such a kind of a bond which is going to take place due to sharing of electrons is called as covalent bond. Okay, a covalent bond is a bond which is taking place due to the sharing of electrons between two atoms. So yeah, generally it will be non-metals. So we can see over here that noble gases will not require any kind of bonding to take place because they are already 8 in number. So each and every other element will require to complete its orbit similar to that of a noble gas. So they will try to do some other method, use some other method by which they can become a stable electronic configuration. That means having 8 electrons in outermost orbit or 2 electrons if it is only the first electron orbit. So we see that the method will be either electron transfers, that is electrovalent bond or ionic bond, or it is by sharing of electrons, that is covalent bond. So the reason for chemical bonding is, as we say, the driving force for atom to combine is related to the tendency of each atom to attain stable electronic configuration of the nearest noble gas. This is the main reason. Okay, the main reason is to attain stable electronic configuration, because this is also because if it is not stable, it cannot exist freely in nature. The next is the periodic property which affect the chemical bonding formation. So there are certain kind of, we had learned in the earlier chapter, the periodic table, that there were 3 properties: ionization potential, electronegativity and electron affinity. So electron affinity and electronegativity and ionization potential, these are the three properties which are going to be very important in the formation of any bond. Because whenever bonding takes place, at that time the bonding is going to be very much dependent on the ionization potential, electron affinity and electronegativity of that substance. Only then it is possible to have a stable molecule formation. So first thing is that, let's talk about ionization potential. What is ionization potential? If you remember, it was nothing but the energy required to remove an electron from outermost orbit. So again, in metals the ionization potential is less, so it is easier for the metal to lose electrons. So that's why metals will have low ionization potential, hence it is easier for them to become a cation easily. Okay, next is electron affinity. What is electron affinity? It is the amount of energy released to accept an electron and become an ion. And a chlorine is having the capacity to release that one energy that can pull out the electron from the sodium atom. That's why ionization potential, the electron affinity of chlorine will definitely be greater. That means that non-metals have got greater electron affinity. This becomes easier for them to become anions. Okay, this enables them to become anion easily. And next is electronegativity. What is electronegativity? That is the tendency of the atom to attract the shared pairs of electrons towards itself. यहाँ पे शेयर पेयर्स ऑफ इलेक्ट्रॉन्स है, उसको खुद की तरफ अट्रैक्ट करने का जो प्रॉपर्टी है, द टेंडेंसी टू अट्रैक्ट द शेयर पेयर्स ऑफ इलेक्ट्रॉन towards itself and formed into a compound is electronegativity. So automatically, if the electronegativity is there, then if the electronegativity of two substances are same, then they will share them equally. If they are not same, they will not share them equally. Okay, so accordingly, larger the electronegative difference between the combining atoms, electron transfer takes place easily also. At the same time, when we see about the electronegativity of this and this electronegativity very less, this very high, hence it is easier for this to accept the give away the electron and this to accept the electron, because this is going to pull the shared pair of electron towards itself much more. So ये छोड़ देगा उसको और ये रख लेगा उसको. So hence we see that for formation of covalent compounds, ionization potential, electron affinity and electronegativity is always high between both atoms of elements. So in case of covalent compounds, ionization potential, electron affinity, electronegativity all should be high because they are non-metals. They are normally done in non-metals. Whereas electronegativity difference should be negligible so that the bonding is easy. So their sharing is easy. So here that is the main part about the periodic table which is connected to the chemical bonding. So now we see the first kind of bond, which is electrovalent bond or electrovalent compounds. Talking about the electrovalent compounds, as I said earlier, that electrovalent compounds are going to be formed by give and take of electrons. So it will be the metals which are going to lose electrons and become a cation, that is positively charged. Non-metals are going to gain electrons and become anion, that is negatively charged, and then this negative charge and positive charge attract each other to form a compound. Such a compound formed due to transfer of electrons is called as electrovalent compound or ionic compound. The bond will be electrovalent bond, electrovalent electrovalent bond or ionic bond. Okay, so electrovalent bond or ionic bond is going to be formed when a metal loses its electron, becomes positively charged, and the non-metal gains electrons and become negatively charged, and this positive and negative charges are going to attract each other and hence form into a compound. We can take a simple example over here that let's consider there is one X which has lost electron and become X plus, and the Y has got accepting that electron and become Y plus, hence the formation of XY as a molecule is going to take place. For example, if you take about sodium, that is Na has got atomic number 17, so protons are 17, electrons are 17. So this out of the 17, 11 and 11. So this 11 is nothing but 2, 8, 1. So this 1 is going to be lost. So after losing 1, it becomes 10. And accordingly, this is now 11, protons 11, electrons 10. So it becomes Na plus. You take chlorine, chlorine is 17. So that is has the atomic number 17. So it is protons as 17, electrons as 17, which is 2, 8, 7. So it accepts this one electron which was there, it accepts over here, so plus 1 to make it 18, hence it becomes Cl minus. And hence the formation of Na plus and Cl minus forms NaCl. So this is how the electrovalent or ionic compounds are going to be formed. So we know over here that the chemical bond formed between two atoms by transfer of one or more electrons from the atom of a metallic or electropositive element to an atom of non-metallic, that is electronegative element. Okay, we see the definition once again, that chemical bond formed between two atoms by transfer of electrons from a metallic, that is electropositive element, to a non-metallic, from a metallic to a non-metallic, okay, is called as electrovalent bond. The chemical compound formed as a result of that is called as a electrovalent compound or an ionic compound, which is nothing but the combination of a metallic and a non-metallic or electropositive and electronegative elements. So electrovalency, the number of electrons donated or accepted by the valence shell of an atom of an element so as to achieve stable electron configuration is called as electrovalency. So if it is going to lose electron, it becomes electropositive. If it is going to gain electron, it becomes electronegative. Positive valency is electropositive elements. Negative valency is electronegative elements. So this is how we see that all the metals, they are going to lose electrons and are going to form into the respective ions. Like ion Fe is losing 2 electrons to become Fe2 plus. When it loses 3 electrons, because it has a variable valency, it becomes Fe3 plus. Similarly, Cu will be a Cu1 plus or Cu2 plus. Mg is 2 plus because it is going to give away 2 electrons. So accordingly, we have got different formations or different kinds of positive ions. Similarly, we know that the non-metals, that is chlorine, will be taking away 1 electron, accepting 1 electron, so it is going to be Cl1 minus. Similarly, sulfur is going to lose 2 electrons, gain 2 electrons, sulfur is going to gain 2 electrons to become S2 minus. Then there are radicals like sulfates, carbonates, nitrates, they all forming a negatively charged ions. So these ones. Now also one more important thing is that whenever a electrovalent bond take place, okay, whenever there is a possibility of an electrovalent bond formed, it will be seen that it will always be a redox reaction. Why redox reaction? Because we very well know that when you lose electron, loss of electron is oxidation, and gain of electron is reduction. So when you see this particular thing, loss of electron is oxidation, that means the metals get oxidized, and gain of electrons is reduction, that means the non-metals are getting reduced. Accordingly, we have that all the electrovalent bond formation all the electrovalent bond formation are redox reactions. So now we have got in the chapter certain kind of examples. They are very simple examples over here, so we need not go through them all together. But and also one more thing, that we are not having the structural diagram any longer. Whenever you are asked to draw the formation of compounds, you will be only drawing the dot diagrams. So according to that particular dot diagram, the first dot diagram will be of NaCl. So Na you have to draw like this, plus, so it will be having one dot over here. Then Cl will be like this, so it will be 1, 2, 3, 4, 5, 6, 7. You are going to show this as an arrow like this over here. And after showing this, you are going to make this like this and make this a bracket with Na plus Cl minus like this. So this will, of course, you will show the 8 electrons now in the outermost shell over here and becomes minus, and hence we see the formation of NaCl. This is the dot diagram for NaCl. So Na plus Cl, this is 2, 8, 1, this is 2, 8, 7, okay. And after that thing, you don't need to write anything over here. You can just write this much in the formation of NaCl. Similarly, you can have one for CaCl2. So it is calcium oxide, that is CaO. So Ca has got the outermost orbital at 2, 8, 8, 2. So there are 2 electrons over here. Plus O will be having, so here O has got 1, 2, 3, 4, 5, 6. So one goes here and one goes here to give me, so this is 2, 6. And accordingly, I am going to have this first one as Ca2 plus and plus O2 minus and giving me CaO. So this is the formation of CaO, calcium oxide, by dot diagram. The next what we can have is the one for MgCl2. So for MgCl2 we are going to use similar thing. So Mg we know that's 2, 8, 2. So it is Mg, which is 2 over here, which is 2, 8, 2. Now Cl is only 1, so we are going to take 2 Cl over here. 1 Cl, we have 1, 2, 3, 4, 5, 6, 7. Another Cl over here, 1, 2, 3, 4, 5, 6, 7. One goes here, one goes here with a plus sign over here, and this becomes 2, 8, 7. And then we are going to show it over here as Mg, formation as 2 plus, and then because there are 2 over here, we'll just write over here 2, and then we will write Cl and then minus over here, and giving the formation of MgCl2. So this is how you are going to draw the dot diagrams for the case of electrovalent bonds. So electrovalent bonds, you are going to draw only the dot diagrams. So normally the ones which are going to be asked will be these 3, that is NaCl, CaO and MgCl2. Even if something else, you know how it can be placed this way. So the formation will be, this is before the combination, this is after the combination, hence the compound. This is how you are going to draw the electron dot diagram for electrovalent compounds.